Hi, my name is Anthony Su, and my coworker Minzy Tao and I are part of Tencent Cloud's international team. And we're both responsible for the cloud ecosystems and partnerships area. So we're very honored to be able to discuss the topic of gaming cross borders for global distributed databases on Tencent Cloud for this DSS summit. The agenda will cover a brief overview of Tencent and Tencent Cloud. We'll look into a deep dive into the game architecture and deployment strategies. Lastly, we'll do a demo of Yugabyte on Tencent Cloud on a global scenario. So Tencent was founded in 1998, and it's a world-leading internet and technology company that develops innovative products and services to improve the quality of life for people around the globe. So Tencent is one of the top 10 largest companies in the world in terms of market cap and one of the largest technology companies in the world. Our corporate strategy is to connect people with services, and connect people with devices. We have focused very heavily on cloud, big data, and artificial intelligence. Tencent Cloud is Tencent's public cloud platform that focuses on enterprise services, entertainment and media services, and social and mobile services. Tencent Cloud is currently the 6th largest infrastructure as a service provider in the world, and we've been growing over 100% year over year. We've been recognized by many leading analysts such as Gartner, Forrester, and IDC, and consistently gotten into the top reports such as Gartner Magic Quadrant for cloud infrastructure and platform services, and IDC MarketScape Worldwide Public Cloud for infrastructure as a service. And we're also trusted by leading companies globally. Tencent Cloud has a very comprehensive cloud product portfolio with over 200 plus supported solution scenarios that covers infrastructure as a service, platform as a service, software as a service, as well as security management tools. Tencent Cloud has specializations in many industries such as gaming, healthcare, retail, finance, education, and so forth. Tencent Cloud has an extensive global presence with 26 regions and over 70 availability zones around the world, with heavy emphasis and coverage in Asia Pacific. Tencent Cloud's global network backbone is all interconnected with full redundancy in a dual ring network design, ensuring that there's always a pathway from one region to another. Tencent Cloud has over 2,800 plus points of presence around the world. 2,000 is in China. These are for the purpose of CDN acceleration as well as DNS. But we have recently released edge compute machines to allow processing on certain edge locations. Tencent Cloud has a very comprehensive compliance certification and attestations. This is a highlight of some of the key global certifications, such as the various ISO and SOC certifications, as well as industry-focused compliance such as PCI and HIPAA. Tencent is the largest game developer and publishing company in the world by users and revenues, and we have a lot of experience in gaming. So we'll do a deep dive on this use case and discuss about how a global distributed database can benefit the game architecture and deployment process. So gaming usually falls under 4 types of deployment models. Each type usually has their use case, as well as advantages and disadvantages, and we'll delve into each. The first type is the global centralized model. The second type is the local centralized deployment model. The third type is the global distributed deployment model. And the fourth type is the regional distributed deployment model. Now, with global distributed database, we'll introduce a 5th type, and what are the benefits of that? The global centralized deployment allows for global access with infrastructure deployed in one region, serving global players You can have acceleration tunnels that can interlink you to any region in the world. This is showing GAAP, which is a Global Applications Acceleration Platform, which is one of the services offered by Tencent Cloud. This helps to link regions in the US to users in other countries or one country to another. The application scenario for this is for latency in sensitive games, where network latency is not that sensitive. Uh, these are like card games, tower defense, leisure games, business simulation games. The advantages of using this are that it's fast deployment, the operational convenience. You can connect global players around the world. And the disadvantages are that the network latency for remote access is not very good. There's also no remote disaster recovery for this type of deployment. The marketing campaign localization is limited, and the user data, there's also user data protection compliance issues around this. This is one way for allowing, the first way of allowing for game deployment. The next deployment model is the local centralized deployment, which allows for regional access with infrastructure deployed in one country or region serving their respective regional players. So the advantages of this deployment model is that you can have a standalone deployment by country or region, and you can have targeted localization campaigns. And you're only regionally impacted whenever there's an issue that crops up. And you can have a major release replicated country by country. The disadvantages of this model is that games need to be modified to cater to global players in different countries or from different cultures. There's also there's a complexity in the deployment, and there's also time consuming for global coverage, as well as slow global rollout of any changes to the games. There's a high operations cost associated with this, as well as especially for potentially low resource utilization in some specific regions or areas. The third model is the global distributed deployment, which allows for platform services deployed in one region and dedicated game servers distributed across the globe. The application scenario for these type of games where network latency is sensitive. This is for social networking based real-time battle games. For the advantages of this is that you get access to the closest point with very smooth gaming experience. It's also easy to spin up a fleet of game servers in this model. The disadvantages of this is that deployment operations can be difficult. You can have there's the difficulty or the challenge of localized marketing and operations as well when you have a global distributed deployment model. The network latency between platforms and dedicated server groups could also be an issue. You also have the issue of user data protection compliance, such as GDPR, that you have to account for. And you also have cross-region failover and on platform services as well. The fourth model is the regional distributed deployment, which are deployed by continent, language, or time zone. The application scenarios for this model is that you have network latency sensitive type of games and real-time battle games. For example, these are MMO games, ARPG games, first-person shooter games. And the advantages of these are that it allows for the nearest access point with smooth battling experience. So it also has automatic failover between dedicated server groups. The disadvantage of this is that the deployment and operation, you have deployment and operations complexity, basically. The fifth model that we would like to introduce, this is with the combination of a global distributed database is a model that combines centralized architecture and distributed architecture in some fashion. So it has all model has all the advantages of the distributed deployment plus lower deployment and operations complexity as well. So this model allows for the nearest access point with smooth dialing experience, and it also allows for automatic failover between dedicated server groups. And there's more seamless deployment and operations. So the disadvantages of this model is really minimal. Okay. So exactly how do we achieve this? How do we, with the global distributed database, there is always a concern with, remember what we mentioned about the data sensitivity across regions. When you have a global when you have a global or distributed deployment. On the previous slide, what I didn't address is that this disadvantage of this new model for leveraging the global distributed database was that discussing about the data protection compliance, such as GDPR in Europe, or a PIPL in China, or a CCPA in the US. So how Yugabyte handles this is by the process of geo-partitioning. So what you can accomplish through this is the PII data or private data you have categorized can remain and is only accessible in the region and origin region of origin. So basically, you can retain that base through geo-partitioning. You can just keep that sensitive data in that region and not have it replicated into other regions. So while you don't replicate the sensitive data, the data that is not sensitive can be, or non-private or data is automatically globally replicated. So you also can create replicas as well from this to even increase in performance further. So now we'll move to the demo portion where we'll demonstrate Yugabyte's multi-region deployment on Tencent Cloud Connect. That's our inter-network connection, global internet network connection, and also our Tencent Kubernetes engine, which is our managed Kubernetes engine. I'll hand it over to Minzy Tao, who will actually do this demo.
Welcome to the demo part, everyone. Here I will show you how to deploy a basic multi-region Yugabyte cluster on our Tencent Cloud Kubernetes engine. You should be able to reproduce what I'm going to do in 1 to 2 hours if everything goes smoothly on your end. To save some time, I've already spun up the server and did some necessary settings. And here I assume that you already have a Tencent Cloud account. If not, feel free to register one at our international websites. Okay, now let's get started. First is to set up the TK cluster properly. To do so, you need to create a VPC and the TK cluster and storage class in each region you choose. Here I select Frankfurt in Europe, Silicon Valley in North America, and Singapore in Asia. And it doesn't have to be 3, it can be any number. Also, please make sure that all VPC seed blocks are not overlapped, as we need to interconnection in the next step. Here we can see the TK cluster running in 3 different regions. This is the one running in Silicon Valley, and this is the one running in Singapore. This is the one in Frankfurt. Also, we can configure it on kube control. After you configure it, you should be able to see 3 clusters through command lines. Here we go. After we set up the cluster, now we need to configure the DNS and routing. Our Tencent Cloud has a product called CCN, Cloud Connect Network, which can connect all VPCs in different regions through internet. After you configure the CCN, traffic between different regions VPC now goes through high-quality private network, and all the TK cluster can also communicate with each other through private network. So here, if we want to set up the DNS, so we only need to get the private IP of our core DNS for each region and configure our DNS core file accordingly. So here, let's get the IP address of our core DNS server. Okay, we got the IP. We should copy it out and configure it in other two regions accordingly. After you successfully configure it, you should be able and apply it. You should be able to check it on your YAML file. As I already did, let's see what I got on the YAML file for Silicon Valley region. You can see here, there are the two blocks that are added. So the traffic from Silicon Valley can be routed to the cluster in Singapore and Frankfurt. Okay, that's all we need to do for the DNS part. It's simple, right? After this step, let's install the Yugabyte database on our TKE. I will use Helm to install it here. So here first, we need to create some override file for each region. The detailed file, you can find it through this link. And also, it's also available on the Yugabyte website. After that, we need to add YugabyteDB chart repository into the Helm. Okay, let's go to the command line. Let me clear it. As I already added it before, so it told me that it already exists. If it is first time for you, you should run the repo updates. Update the repository accordingly. As it will take some time, I will not run here. After you do the updates, you can do the search to see if the chart is there. Yeah, there we go. We can see the Helm can find the Yugabyte repository. Now we can start to install it. Here we will use this command line for each region. As I already installed it, I will just paste it here. When you get successfully installed, and if everything goes well, let's check. We should see the cluster is up and running. Let's check if everything is running properly. Here I will just use Silicon Valley region as an example. So first, let's check the port. It's good. And now let's check the servers. It also runs well. So the last step is let's check it on the UI. So we copy the external IP here. We go to the browser, paste the IP and the port number 7000. It looks also good. We can see that there are 3 clusters is running. 3 servers is running in 3 different regions: Silicon Valley, Singapore, Frankfurt, and there are 3 nodes here. Now I'm going to use a very long command line. Let me paste it here. This command line is going to make the replica placement regional aware so that one replica is placed on each region. And if we don't do this step, the default replica placement policy treats every Yugabyte T server as equal irrespective of its placement flags. Okay, so after you run this command, you should be able to see your new configuration is active on the UI. There you go. Okay, if you go successfully through all these steps I've talked about, well, congratulations. Now you have a YugabyteDB class, Yugabyte database running globally, and you can go to one of the T servers that is closest to you. For me, it's the Silicon Valley server. Let's connect to it. Okay, we successfully connected to it. So let's try to fit some data into a table that I created before. Let's see if we can count how many rows I have for the table, for the user table. Yep, so it looks like everything goes well. So the user can start to try to get more data to fit more data into it. So this is what the step 4 is just what I just did on the browser and the terminal to check the status, the cluster status, to access the master server through admin through the UI and connect to the cluster use the shell. Here I use the YCSB Yahoo Cloud Serving Benchmark and run some test data on the cluster we just talked about. From workload A to workload F, we can see some very outstanding performance, considering the database is strong seen globally among Europe, Asia, and North America. As we don't have too much time here today, I will not dive into it. I will just stop here, and thank you guys for watching the demo.
Thank you, Minzy, for doing the demo. And lastly, we want to thank everybody for their participation. Please follow Tencent Cloud on LinkedIn, Facebook, Twitter, and YouTube. Again, I want to thank everybody for joining us on this session, Beyond Borders for Global Distributed Database on Tencent Cloud, for the Distributed SQL Summit.